Okay, hello the viewers. It has been quite a while. Sorry. Alright, so let's say you have going to have an exam or quiz preparation. Okay, you're going to have soon exam quiz soon, and you still do not know how to do Newton-Raphson. Right, so don't worry. I got mostly of the stuff covered over here. Okay, so let's begin. But before we start on the big question, so let's have a look on this small stuff. Okay, let's say if you want a 4 decimal for our final answers, right? And you are given these two equations, these two values here, where there are 5 in decimals. 1.31248, another one is 1.31252. My question is, do these two values has the same value? Alright? Right, sorry, grammatical error over there. So what do you think? In this case, since I want the answer in 4 decimals, so I need to round it up first. After rounding, then only we get the same values. So yes, they are the same. Right, so be careful. You need to see in 5, then you need to round into 4. Okay, keep this in mind. We're going to use this over and over again. Alright, so let's continue. Okay, why do we need to learn Newton-Raphson? Well, in the past, people do not have a computer, they do not have a calculator. So let's say if you're given this simple equation and they want to know the root. So x squared minus 5x plus 6 is equal to 0. So the root is, you can easily calculate 2 and 3, and you can even see from the graph, it lies over there between 2 and 3. Okay, so that's easy. Now what happens if I give you a hard equation, something like this, 2 exponent x plus x squared minus 4 equals to 0. Now give me the root, find me the root. Things are going to be very difficult. So this is where you need to use the Newton-Raphson way. Okay, so let's begin. Let's say if you have yourself like this question, it's a normal exam question. We want to show that this root firstly has the root lies in the interval of 0.55 and 0.65, and we want to find the root by using a Newton-Raphson. Okay, so how do we start? Well, firstly you need to write down the equation, and we need to move this 4 to the other side, so that we have equals to 0 on the right hand side. Okay, and then the one that with is equal to 0, we make it into here, into fx. For fx equals to 2ex plus x squared minus 4. Alright, so then only we can start calculating. Firstly, we want to show the root. We want to show the root lies first. Okay, lies in the interval. So by taking those values, so 0.55 and 0.65, alright, so we substitute those two values into the equations, and you got this. 0.55, 0.65, you calculate it out. For the function f, 0.55, you got yourself into negative 0.23, and the other one, you got yourself into positive 0.65. You need to write down this line where the one of those is less than 0, another one is more than 0. You need to write it down. If you don't write it down, then you will lose your mark. Then only you can write down this conclusion. You must write this conclusion where f 0.55 is less than 0 and function f 0.65 is more than 0. So fx has a root lies between 0.65 and 0.65. You need to write the whole thing. Okay, so from here we can conclude that as well, that our initial approximation where x0 is equal to 0.6. So that is where we're going to find. But 0.6 is still not yet entirely accurate. We need to use Newton-Raphson. Okay, but I've put this value into the calculator, put the graph into the calculator, so we can have a look. See, our graph here lies between 0.55 and 0.65, and if we zoom in even further down, we can see it lies somewhere between 0.5991. Okay, so still somewhere in between of those. So even the computer calculator has not enough power to accurately calculate it out. Okay, so let's begin by Newton-Raphson. Okay, firstly, if you want to use Newton-Raphson, this is the formula. Remember over here is minus. I myself make a mistake that I put it plus in my class, which is an embarrassing mistake. Okay, hopefully you will not do the same mistake as I did. Okay, and then we continue out. Firstly, you need to differentiate, and you can see here for the fx it lies on top, and the other one, the differentiate, it lies at the bottom. Alright, so just to visualize things out for you. Okay, then we start with the initial approximation where x equals x0 because 0.6. In some question they do x1 as your initial approximation. In some question they do as x0. So it depends on the question that you got. So we start with the 0.6, so we want to calculate this x1. So you basically need to replace the x0 with the 0.6 here. You don't need to write this in this line, you can straight away jump to the second line. So this line and that line, I just want to visualize things out better for you. You put the calculation key inside your calculator and you should get these two values, okay? Firstly, you got yourself in the 5 decimals and then you round it up to 4 decimals. Okay, why do I get to 5 decimals? Because the question 1 in 4, so firstly you calculate to 5 and then we round to 4. And then here you can actually already start comparing. You can start comparing these two. Do they have the same values? In this case, they are not the same values, so we continue with the calculation on the second x2. So you continue it again. Alright, put the calculation, and in this one here, as you can see, I'm using the 0.591913. I'm using the 4 decimals. I'm using the 5 decimals. One moment. Okay, let's continue. I got a phone call just now. Okay, so once we got here, now you see that we are calculating this value when we rounding things up. Okay. When we round up, it has the same values, 0.5991 here. It has the values to 0.5991 up there. So when they have the same values, then only you stop calculating, because that's your stopping criteria. Okay, and then you give your answers. The x root is 0.5991. So let me rephrase here. This is your stopping criteria. What happens if we don't stop? If we do not stop and we write down another equation, another calculation, then you'll be penalized by 1 mark or 2 marks, because they say to you, hey, this guy do not know when to stop. And let me rephrase it again one more time, that you stop it when the rounding answers, the rounding values are the same. Okay, so you stop there and that's your final answers. How are you going to calculate all these things? I prefer this using the answer method. They are a formula method, a program method into your calculator, but I just do not get it too much. Things sounds more complicated here, or you can just go to this video which I put in the link description down below. It has a similar question which I write it down last year. I recorded it last year. You can have a look over there. Okay, so let's continue with another example. Okay, this is a very important moment here. I got a student she is a very smart student, but she made a mistake over here, and she in her quiz she got a C, but on final she got A. So I hope you will not make the same mistake as her. Okay, so firstly, if you want to find the calculation, find the value by using Newton-Raphson, differentiate things up. Alright, so firstly we diff, and then we put it inside the equation as 0.5 and put it into the calculation over here. Okay, you may pause the video, which I encourage you, and then you may press into your calculator and see whether we get the same answer. Unpause if you have done it, or you're cheating around. You should get yourself into here. You might have a different answer with me, because you must calculate this in radian, not in degree. So if your calculator is still in degree mode, so it need to be radian. I'm sure you can see it. Need to be radian over there. It's harder in left and right. You got the idea. If you calculate in degree, so goodbye for you. Around 10 to 50 marks. So make sure you got your mode correct in your calculator. And the rest over here I calculate along for you, and as you can see, I only take the value when it's round up, when they have been rounding. It might be round up or round down. So our root lies, as x root is 0.739. Okay. Another example which I would like to give to you is this one. I got a lot of, even a genius student or good student, they forgot on how to do this one. Okay, so let's say if you're given here cube root 15, and they just want you to find the approximation. Okay, I did not do Newton-Raphson, but I just do the how we find the root where it lies, because that's what I want to show right now. As you can see in this calculation, in this question, there are no x. Okay, let me show you a question before this. But in this question, but we have done before this, as you can see, there's x and that's equal. But just now it's just a cube root 15. So how do we start? Alright, firstly you need to do let x equals to cube root 15, and then you may rearrange it out in any way you want, but I find this to be the easiest, where you cube both sides, make the cube root disappear and bring it to the other side where equals to 0. And remember, once you get the equals to 0, we let fx equals to x cubed equals to 15. X cubed minus 15, right? So that's how you do, and the rest of the work are pretty much the same. But in this question, you are not given any roots, initial approximation. So how are you going to find the initial approximation? You may do it in this brute force manner. Alright? You may do it in brute force, and you can see only for these two, the last two here, where things are 1 is less than 0, 1 more is more than 0, so that's where your initial approximation going to lies, which is around 2.5. Okay, you must write down the whole thing. And someone might ask, must we really calculate one by one? Brute force, yes, but there's a quick way on how you want to find it. You can do it this way, where x cubed equals to 15, so 2 cubed if you 8, which is less than 15, and 3 cubed is 27, is more than 15. Okay, maybe it's better if I move this a bit. You got the idea. Right, so as you can see here, 2 and 3, so then only you can skip the whole thing, quickly come here. Alright, okay, I think that's all for now, and it should be enough information for you to enter your exam or quiz. There is another way of showing root. I do not show here. Showing root lies by graphical method, but that's quite a long topic, and normally in exams they don't force you. Normally in exam they said, oh, just show us the root, and you may use another way. But who knows, maybe in this year they want to find, they might want you to find it by using graphical method. So yeah, that's another topic, and that's all for now. Alright, thank you for watching. All the best for your exams, and bye. Please comment, share, like, subscribe down below. Help me to get 3K. We're almost there. 3K subscribers. Send this to your friend. Ask them to subscribe.